Okay, so good day. So ang topic natin ngayon is all about what we call the torsion. Okay. So ano yung torsion? So balikan muna natin, no? So before, okay, i-drawing ko ulit yung parang beam natin. Okay. For example, that is the cross section. Binanggit natin. Meron tayong different axis, no? Local axis, we have the X, the Y, and then the Z. Okay? So, meron tayong direct forces. So, we have the Fx, the Fy, and then we have here the Fz. And all of these forces have different types of stresses na nakikreate dun sa ating cross-sectional area. So, I'm speaking of the cross-sectional area for this one. Okay? So, sabi natin, itong Fz natin, it create an axial stress. Okay? Axial stress. And then itong dalawa, they are both shear stress. Okay? Kasi they are parallel dun sa ating area, wherein the axial stress is yung ating perpendicular dun sa area. Okay? Now, we will be having first the one type of the moment. No? So, aside from three forces, meron din tayong tatlong moments. The Mx, the My, and then the Mz. Okay? So, ngayon, ang pag-aaralan muna natin is this Mz, or the moment about Z. So, this Mz, ang tinatawag nating torsion. Okay? Or twisting. No? Pag tinitwist nyo yung ballpen nyo, okay, those are types of twisting. Ito yung area, no? So, kumbaga, kung iti-twist ko tong ganito, so, pwede siyang matwist parang in this direction. Okay, so, iikot siya. Okay? So, pinakasimple, ang ating tawag natin dito, ang pinakasimple is yung ating tinatawag na circular shaft. Okay? So, parang ganito, circular. Okay? So, may assumption tayo pag sinabi nating shear stress, torsional shear stress. Papaliwan natin mamaya kung bakit yung torsion ang nag-create ng stress dun sa ating body is still shear. Okay? Shearing pa rin. Kaya ang tawag sa kanya is torsional shearing stress. Okay? So, isa kasi sa pinakamagandang cross-section area para sa torsion as circular. Okay? So, una, pag dumating tayo sa shear flow, okay, makikita natin na maganda yung shear flow doon. Pangalawa, hindi siya nagwa-warp. Okay? Pag sinabi kong nagwa-warp, okay? So, for example, pinaikot ko to. Okay? For drawing na ako. Sige. Example, ito yung pinaka, tapos iti-twist ko siya. Okay? Papaikutin kong pa ganun. Okay? So, lagyan natin, okay, at this point, okay, hanggang doon, tawag ko itong point A, and tatawagin ko itong point B. Okay. Kung ito ay rigidly fixed, okay, let's say, fasten siya rigidly sa one end. So, papaikutin ko to. Ano sa tingin nyo yung magro-rotate? Okay. Itong A, since this is fixed, okay, ibig sabihin, hindi gagalaw yan. So, wala kang makukuhang movement dyan. Pero itong B, pag pinaikot ko yan, itong B pwedeng mapunta at this point. So, tawagin ko yung B prime. So, meron na ako ngayong deformation doon. Okay? Kumbaga, itong surface ko na to, umikot na siya. Okay? So, iyon yung kukunin natin. Isa sa kukunin natin yan. Ano? Okay, now, when it comes to what we call the compatibility from this figure, kukuha lang ako ng infinitesimal. When I say infinitesimal length, maliit lang. Siguro, maliit na length lang. Okay, i-drawing ko dito, tapos medyo lalakihan ko. So, ayan. Hop. Hop. Tapos, example lang. Yan. Example, ayan yung length na yun. Since, pag sinabi yung infinitesimal, kumukuha tayo ng very small. Okay? So, instead na total length natin siya, okay, total length natin siya, gagamit ako ng dx. Okay? Di ba? Pag gumagamit tayo sa calculus, gumagamit tayo ng term na dx. Okay? And then, lagyan natin ng point. So, ginamit ko na A and B. So, lagyan ko to ng point A and then gawan ko to ng point B. Okay? So, ito yung ating initial, okay? Initial na line, okay? Ngayon, papaikutin natin 'yon. Okay? Kapag pinaikot ko 'yon, ay, nagamit ko na pala A and B, sorry. Buray natin. C and D naman. Ayun. Gamitan natin ang C, and then this one is D. Okay? Pag pinaikot ko yun, okay, assuming na fix yung other end, yung one end, so yung D yung mapupunta rito. No? So, example, ayan, mapupunta dyan yung D prime. Okay? So, from C to D, okay, from this C to D, napunta na from C to D prime. Okay? Nagkaroon na siya ng deformation. Okay? Ngayon, yung deformation na yun, actually, so, tinatawag natin siyang shear strain. Okay? So, yung shear strain natin, actually, it is just parang tangent lang siya, no? Or parang tangent lang siya. Now, ngayon, yung deformation na to, syempre, from the center, okay? Ayan, meron kasi yung center, di ba? Okay. Ayan, from that center, okay. Yung tunay niya, meron siyang radius R. Okay? Pero sa atin, ang gagawin natin, it is just a radius. Okay? Tawagin ko siyang rho. Okay? So, from this point O to point D prime, tawagin ko siyang rho. Okay? So, yung deformation na to, okay, yung theta, yan yung hinahanap natin. Ano yung deformation dun sa pinaka-section natin? Ano? Gaano kalaki yung inikot niya in region. Okay? Now, para makuha ko siya, or para makuha natin siya, kukunin muna natin tong shear strain natin. Again, dapat yung shear strain natin, it's the measurement, parang tangent, opposite over the adjacent. So, ang opposite niya, itong line na to, which is D prime, all over CD. Okay? Now, yung D prime ko, okay, kailangan ko siyang makuha in terms of this one. So, D prime gamit yung triangle na to, I could say that would become equal to rho multiplied by the theta. Okay? Tangent lang naman, ano? So, kasi yung tangent of theta for a very small, by the way, for a very small, infinitesimal pala to, so we will have just d theta. For a very small angle, okay, yung tangent of theta mo, okay, for a radian, is also equal to theta. Okay? For very small angle. Okay? For a very small angle, the tangent of theta is also equal to theta. So, it means if I'm going to have it the rho, and then tangent of d theta. Okay? Yun siya, no? So, it would become equals to rho, and then multiply it by d theta. So, yun siya. Okay? So, substitute ko. So, yung shear strain ko, d prime is rho d theta all over the CD. Yung CD ko is actually my dx. Okay? So, this one, okay, itong d theta, itong term na to, okay, yung d theta, oops, I think, naanohan ko na siya. Yan. Okay, so ulitin ko, no? So, you have here the d prime all over the CD. Saan ba hindi kita kanina? Para, ano, okay, nandito kanina yan eh. Okay? Okay. D theta, yun. So, ito, sinubstitute ko lang, no? So, yung gamma natin, or yung shear strain natin, yung DD natin, DD, ito yun. So, rho d theta. And then, the CD is actually the dx. Okay? So, itong d theta all over the dx, actually, ang tawag dyan is, that is the angle of twist. Okay? So, that is the angle of twist. Okay? So, mamaya yun yung mahanapin natin. Okay? Now, from that angle of twist, okay, kukunin na, para makuha naman natin yung kanyang stress. Okay? So, di ba meron tayo for the shear strain. Okay, yung shear strain natin. So, that would be the G multiplied it by the strain. Okay? So, ito is modulus of elasticity. and then the gamma is actually the shear strain. Okay? So from there, pwede kong sabihin that my shear would become equals to G d theta all over dx multiplied by rho. So, saan galing yun? Yung gamma, ito sinubstitute ko lang, no? So, nire-arrange ko lang. So, that would be our shear stress. Okay? Now, we could say that yung ating stress, mapapansin natin, ang relationship niya dun sa rho, which is the angle, is directly proportional. What does it mean? Mentrans na lumalaki yung rho from the center, lumalaki din ang stress. Okay? So, paano yun? For example, ito yung cross-sectional area niya. Okay? Ito yung center O. And then, ito yung R. Mentrans, malapit dito, kaunti lang. Habang lumalayo siya, tumataas yung kanyang stress. Okay? So, it means, mas malayo yung point dun sa point of rotation, which is the point O, mas malaki yung stress na nakukuha niya. Okay? Ay. Yan. Mas malaki yung kanyang stress na nakukuha. Okay? Now, ang gagawin natin ngayon is we are going to derive. Okay? So, how to derive that? Check ko muna yung videos. Okay? So, sige. Find time to copy and then we will proceed for the derivation of the angle of twist. Okay. So, I'll try to delete na. Ako. Hindi ko kabisado. Ayun. Okay. So, okay. Okay. So, balik tayo, no? So, ulitin ko na yung ating shear stress. Ilagay ko lang equation. So, you have the shear equals to G multiplied it by the shear strain. which is also equals to G multiplied by the d theta all over dx multiplied it by rho. Okay? Now, from that principle, okay, kuha ulit tayo ng baka masulatan ko na naman eh. Saan ka muna? Okay. Maglalagay ako ng sorry. Hirap talaga ng online. Shift yun. Shift pala dapat. Para hindi ko masulatan. Lagyan ko ng boundary. Yeah. Okay. Now, to have that, ibalik yung drawing na below. Isa pa, napakahirap mag-drawing sa tablet. Oops. Ayan ang nakakasin. Ano ba yan? Isa na. Ibabalik. Okay. So, let's say ito yung cross-section area and then that is the center O. Okay. And then we experience a torsion T, no? So, yung T natin, that is the torsion. Now, yung area natin, okay, kasi ganun din, kukuha tayo ng infinitesimal area. Let's say, ito, yung area na yan. Okay. So, tawagin ko yun dahil infinitesimal yung area niya, I will call that as, of course, the dA. Okay? Now, from the center O hanggang doon, sa dA ko na yun, yun yung ating rho. Okay? So, ibig sabihin, that is the distance from the point of rotation papunta doon sa certain area. Okay? Ngayon, ang nagkikreate nun, actually, you will be having here what you call the P. Okay, yung force doon or yung shearing stress natin ay shearing force natin ano. Pero dahil infinitesimal siya, tatawagin ko rin siyang dP, ibig sabihin infinitesimal force. Okay? From our stress, 'di ba, yung stress natin, again, that's also the P over A, 'di ba? So to get for the P, you will be having here the shear multiplied it by the alpha. Okay? So that I will be having here the dP equals to shear multiplied it by the area. Pero yung area natin doon is actually the infinitesimal area. So, the area. Okay? So, makikita natin from there na yung ating shear stress, okay, multiplied by the infinitesimal area, that would be the infinitesimal shear force doon sa ating isang area lang. Okay, now, working on this, okay, sabi natin kanina, yung shear natin, okay, substitute that, ilagay ko dun, okay, substitute ko yung shear, so I will be having here the dP, okay, so you will be having here the dP, ayan, equals to, yung shear natin is G d theta all over dx rho, okay, and then multiplied it of course by the area. Okay, so yan na siya. Ngayon, para makuha natin yung moment about O, okay, so you will be having here, so moment about O, okay, so that would become equals to dP multiplied it by rho. Okay, so iyan yung ating infinitesimal torque. So yung isang torque natin, ano, so ibig sabihin yung ating pinaka infinitesimal torque, so that would become equal to dP. Pero yung dP ko, that would become equals to G d theta all over dx rho dA, and then multiplied it by the rho. Ayun, ayan yung rho na yun, ano. Okay. So, pwede nang pagsamahin. So, I will be having here the dt equals to G d theta all over dx rho squared multiplied it by the dA. Okay? Now, to solve for the torque, kasi sabi ko nga, since infinitesimal siya, infinite yung number ng area niyan. Okay? Infinite yung number ng area hanggang sa mabuo mo lahat. Okay? So, napakaraming area nun. Okay? So, ang gagawin natin para pagsama-samahin natin yung effect na yan, ano ginagawa natin? Kinukuha natin, ini-integrate natin para makuha natin lahat. Okay? Sa lahat ng area. Okay? So, that I will be having here the torque. Okay? Yun yung hinahanap natin. That would become equals to, from this one, kopyahin ko muna, from total ng sum ng area, d theta all over the dx cross squared multiplied it by the dA. Now, imagine this, okay? So, since I am after for the dA, ilalabas ko, i-rearrange ko to, no? So, it will become equals to g d theta all over dx integral of a cross squared multiplied it by dA. Okay? Nare-arrange ko lang. Familiar ba sa inyo to? Okay. This is what you call the second moment of area. Okay? So sa statics, no, that is the second moment of area, and that's actually the what you call the moment of inertia. Kaya lang for a circular or for a torsional, what you call the kapag meron ng x and y axis, so tinatawag natin siyang polar moment of inertia. So it's called the polar moment of inertia. Okay, it's a moment of inertia, but because it is the combination of the two axes, x and then y, we call it the polar moment of inertia. And it is denoted by the subscript j. Tama ba? So, it means we will be having here g d theta all over the dx. This one would be referred by the j. Okay? Now, from there, I can say that rearranging d theta all over the dx. Okay, ililipat ko, so that would become t all over j g. Okay? So, ayan na. Medyo lumalabas na, no? Kaya lang, itong given kasi natin, it's only for the x. Okay? Natatandaan nyo kanina, di ba? So, mahaba yon, pero kumuha lang tayo ng maliit, dx lang. Ngayon, gusto nating malaman ano yung effect nun dun sa buong length. So, since dx lang siya, isasum ulit natin yung effect nun from that dx. Maliit na dx, susunod na dx, ayan, parang hinati-hatin, maraming dx, ano? Hanggang sa makompleto natin yung complete L. Okay, so in short, i-integrate natin to from 0 to L. So, integrate natin from 0 to L. Okay? So, that would become equal to this one. However, ito, okay, variable separable, ano, from the dE. So, we can have 0 to L, t all over jg, and then multiply it by the dx. Ito, that would be the theta. Yan yung hinahanap natin from the start, no? And then, we will be having here t and then x all over jg from 0 to L. Okay? So, palitan natin yung x. So, theta would become equals to TL all over jg minus t multiplied by 0 all over jg. So, you can have it, the angle of twist equals to TL over jg. Okay? So, ito yung formula sa pagkuha ng angle of twist. Where the T is the torsion, the L is the length of the member experiencing that torsion, and then the J is the polar moment of inertia, and G is what you call the shear modulus of elasticity. Okay? So later on, we will be having example on how to compute for those. Okay? So for now, time to copy and have your lecture. Sige, idagdag na natin to, no? So, that is the angle of twist. Yung shear stress natin, i-derive na rin natin. Ito kasi yung formula niya, di ba? Okay. Pero, from this equation, okay, yung g d theta all over dx, that would become t all over j, no? So, that will become g d theta all over the dx. Okay? So, ito yun. G d theta all over the dx. So, shear would become equals to T all over J multiplied it by rho. Or that your shear stress would become T rho all over the J. Okay? So, ayan. For the torsion, for now, dalawa lang yung kakabisaduhin. So, you have here the shear stress, torsional shear stress, which is T rho over J, and then the angle of twist or yung deformation niya, para siyang PL over AE, di ba? Parang yan din yan PL over AE So, instead, it would become TL all over JG. Okay. Sige po. Continue copying. Alright. Okay, so nakopya na. So what we will do now, delete ko muna. So balik ko, no? So shear equals to T rho all over the J, and then that would become TL all over the JG. Tignan natin ano. So, how to compute for circular shaft? Okay, we will limit our problem on the circular shaft. No? So, kapag kasi ibang section na, iba na yung pag-compute ng J mo. Okay? So, for a circular shaft, okay, with diameter D, okay, so we will be, we can compute for the value of the polar moment of inertia. Okay, so the polar moment of inertia for this J equals 2, that is pi d to the fourth all over. Laging to the fourth, ano, kasi dapat it should be mm squared or inches to the fourth. So that is 32. Okay, and then pwede ring itanong, we can have it the hollow. Okay, ibig sabihin ng hollow, may butas sa gitna. Okay, parang mga pi. So, you can have it as J, that would become equal. Ganun pa rin, pi all over 32 Kaya lang, we will be having this one is the outer diameter, and then we will denote that as inner diameter d. So you can have this d to the fourth minus d to the fourth. Okay? If the given is r, okay, papalitan mo lang naman yung d equals to 2r, di ba? So that would become pi r to the fourth all over 2. Okay? So ganun din dito, that would become pi r to the fourth all over 2 multiplied by r to the fourth minus r to the fourth. Okay? So yan, palitan nyo lang ng 2r yon. So 2 to the fourth was to 16. So 32 all over 16. You can have it that way. Okay? So ito naman yung ating formula. Now, yung row kasi natin, if I say the row, any distance from here. So pwedeng mula dito hanggang doon. Pwedeng mula dito hanggang doon. Sinasabi nga natin, maintenance na lumalayo, tumataas yung pinaka-shearing stress niya. Okay? So, if ang question is the maximum, okay, yung row natin magiging R. So, mula dito hanggang dun, which is the radius. So, that would become TR all over J. Excuse me. That would be the maximum row. Okay? Now, to solve for the shear stress, i-check natin ano for solid shaft. For solid shaft, ito solid to. Ito is hollow. Okay? So we can have it as the T. Okay? T max, no? Kukunin natin T max. Sabi natin is, it should be the TR all over J. So we can have it as T, R, but ang J niya is pi D to the fourth all over 32. So that would become equals to 32 T R all over pi D to the fourth. Okay? So, this would become equal to T R all over. In terms of D, so yan natin. So that is 32 T multiplied it D all over 2, no? All over pi T to the fourth. Okay? So cancel yung isang D, tapos ito magiging 16. So that would become 16 T all over pi D cube. Okay? So for the T max, ito siya. Or, ito, kapag kinonvert natin, isa na yan. Pero ang gawin natin, yung D naman, ang gagawin nating R. Okay, so that would become 2R cube. Okay. So, 2 cube is 8. 16 divided by 8 is 2. So, that would become 2T all over pi R cube. Okay. So, for a solid shaft, kapag ang given is diameter, you will use this formula. And then, for a given is the radius. Given is, okay, kabisaduhin nyo na lang yung isa. Tapos, substitute nyo na lang yung value ng D as 2R. Okay? For the solid, for the hollow, okay, so we will be having here the hollow. Again, the maximum stress would become TR all over. Unahin ko muna yung D, no? So, I will be having here pi all over 32 multiplied by D to the fourth minus D to the fourth. Okay. Same procedure lang naman pala to. Okay. So, you can have it here as 16T all over multiplied it by pi multiplied it by D to the fourth. Dito, hindi na ito pwedeng 16TD D to the fourth minus D to the fourth. Okay. Hindi na siya pwedeng mag-cancel out ng cube kasi meron ka ng smaller D. Okay. Unlike dun sa isa sa solid, pwede siyang ma-cancel out. This time, hindi na pwede. Okay. So, this now would become your formula. Okay. Parang dun galing. Okay. And then, next, for the radius, so you can have it as 2T R, that is the outer, and then pi R to the fourth minus R to the So those are maybe the things as of now na kailangan nyo matutunan. So this formula, these formulas, and then those formula. Okay? So again, I'll give you time to copy and then we will answer sample problem. Okay, so let's have a problem sample. Again, this problem sample is from Cusalas and Python. Okay. Figure A shows a 2-inch diameter solid steel cylinder that is built in to support at C and subjected to torques TA and TB. Determine the maximum shear stress in segment AB and BC of the cylinder, and to compute the angle of rotation at the end of A. Use G equals to 12 times 10 to the 6 PSI for steel. Okay. So, ang gagawin natin, kasi mahirap mag 3D. Okay. What we will do is, una, pwede natin siyang gawing two-dimensional. Okay. So, paano ko gagawin two-dimensional? So, drawing ko muna. Okay, para lang din yung ginagawa natin, ano? And then this is the point C, this is the point B, and then this is the point A. Okay. Now, ang gagawin natin, we will follow what you call the right thumb rule pa rin, ano? Okay. Ito yung axis natin sa X. Okay. Kapag papalayo, okay, kapag papalayo yung ating tawag natin dito, ating direction. Okay, so pag ganun ano. So, towards the positive x, and that would be a positive 1. Okay? So, ibig sabihin kapag pag ganon, kung nasan yung right thumb ko, pag ganon yung arrow ko. Tingnan nyo yung sa point A. Okay? Pag ganon kasi yung ikot niya. Okay? So, you can have it this parang, I will call that as double-headed arrow. Okay? Yun yung 900 pound feet. Okay? Pag ganon. Now, paano mo papaikutin? Using your right hand, paano mo papaikutin si B? Papaikutin mo ng pagganon. Tama ba? Okay. Pag pinaikot mo ng pagganon, saan nakaturo yung right thumb mo? At point B, dito siya nakaturo. Okay? And then that would become 400 pound feet. Okay. Next. Kailangan maging equilibrium siya. Okay? So, meron akong 900 towards the right and meron akong 400 towards the left. So, kailangan ko pa dito ng another 500. Okay, pound feet. Okay, so para maging equilibrium. Okay? So, that's how, again, you use the right thumb. Isipin mo kung paano papaikutin yung shaft. At point A, paano mo siya paikutin? Gamit yung iyong right thumb. Gamit yung right hand. So, papaikutin ko siya ng pagganon. Okay? So, kung saan nakaturo yung right thumb ko, okay, sa ganun yung direction niya. Okay, so yung 400 pag ganun. Okay, now, from the segment, since dalawa yung segments natin, we have the AB and then we have the BC, kailangan magka-cut ulit tayo ng section. Kasi ang tinatanong sa kanya is the maximum shearing stress. Okay, so we can have it as cut tayo dito. Okay, tapos mamimili tayo at AB, at segment AB. Okay. At segment AB, mamimili tayo ng side. So, I will choose, ito na lang, kasi maliit. Okay, so I have here the A, and then I will be having here 900. Okay. And then, may expose natin the internal force. Okay. And ito yung ating torsion at segment AB. Okay? Ang convention natin ganito. Kapag papalayo dun sa cutting section, okay, kapag papalayo ano? So, we will denote that as positive ulit. Kapag papalapit, we will call that as negative. So, mamaya mahalaga yon para dun sa ating angle of twist. Okay? So, for now, we will be having here on the J. Okay? So, again, yung ating maximum shear stress, kunin muna natin yung polar moment of inertia niya. So, we can have it as J. Okay. Ang given is, we will be having 2-inch diameter. Okay. So, we can have it as pi d to the 4th all over. Ano nga to? We will be having here 32. Okay. So, we can have it as pi. Ang d natin is 2 to the 4th all over 32. So that would become pi multiplied with pi 2 to the 4th all over 32, or that's pi all over 2. Okay, or 0.5 of pi. Okay, or 1.5708. So ang unit niyan is inches to the 4th, kasi ang naka 4th is the D. Okay? Now, to calculate the maximum shear stress at segment AB, so that would become equals to TR, tama, AB, R all over the J. So again, ang T natin is in 900. Okay? Kaya lang naka pound feet to, no? Pound feet. So i-convert natin yung feet into inches. So, para maging feet, maging inches yon, i-multiply natin yon by 12. Okay? And then, ang R natin is, ang diameter is 2, definitely, ang R natin is 1 all over the 0.5 of pi. So, you have the maximum shear stress at segment AB equal to, so that's 900 times 12 all over 0.5 of pi. So you can have it as 6,875.49 PSI. Okay? So this is now the maximum at segment AB. Now, to solve for the BC, again, magkakat ako in between B and C. And then, mamimili ako ng section, right or left lang. Okay. Piliin ko na lang yung left this time, no? Kasi mas kaunti. So, I will be having here, okay, ito yung cutting plane. Again, meron ako ditong load na 500. Okay. And then, makakapag-expose ako ng internal force. Again, this is also 500 pound-feet. Sir, kapag right po ba yung kinuha, same lang yung magiging sagot? Yes po. Dapat same lang yung magiging sagot. Okay? So that we can have the value of the maximum at BC. Again, that would become T BC R all over the J. So we can have it as 500. Kaya lang naka-feet siya. So convert natin into inches. So times 12. Ang R natin is 1. All over ang J natin is 0.5 of pi. So you can have it the maximum stress at BC equal to. So you can have it as 500 times 12 all over 0.5 of pi. So that's 3,819.72 PSI. Okay, so you will be having here the answer for the maximum shear stress at AB and maximum shear stress at BC. Now, ang kailangan natin ngayon is the angle of rotation. Okay? So, to solve for the angle of rotation, okay? Kasi, at the end of A, ibig sabihin sa dulo ng A, dito magbumula yun, di ba? Kasi dito wala kang ano kumbaga, parang ginawa natin kanina, ito yung magro-rotate. Okay, so mula dun. Okay, nahanap natin kung ano yung angle rotation nun. Ibig sabihin, that would be the sum, okay, of the angle of rotation of AB plus the angle of rotation of BC. Okay? So, again, that would become TL, TAB, LAB, okay, all over JG plus TBC, LBC all over the JG. Okay? So, meron naman akong T sa AB. Okay? And then this time, i-denote ko siya as positive. Okay? Kasi again, away from the cross-section. So, I will have it as positive. Kung towards the section siya, you should have negative. Okay? So, 500 times 12. Ang L natin, again, ang L ng AB is 5 feet. So, 5, multiply natin again by 12 para maging inches. Bakit natin kino-convert sa inches? Kasi, naka-inches to the fourth yung J natin at naka-inches din yung ating G. So, dapat consistent tayo, no? Kung inches, inches. Kung feet, feet. So, ang J natin, again, ilan ang J? 0.5 of pi. And then, ang G natin is 12 times 10 to the 6. Okay? So, again, plus ang gagamitin ko dahil yung 900 ko is away from the section. So, I will have it as plus. Okay? So, you can have it as 900. 900 multiplied it by 12. Okay. Then, multiplied it by, ang length is around 3 feet. So, you can have it as 3 times 12. All over JG, 0.5 of pi multiplied it by 12 times 10 to the 6. So that is now the rotation at the A. Okay? So again, we can have it as 500 times 12 multiplied 5 times 12 all over 0.5 of pi multiplied by 12 times 10 to the 6. And then plus, you can have it as 900 times 12 multiplied by 3 times 12 all over 0.5 of pi and 12 times 10 to the 6. Okay, so you can have it as the rad equals to 0.5 0.03973. Again, this is in radian. Okay? Now, to convert that into degree, ilang rad? Okay? So, you can have it as, so, in 0.03973, multiplied it in 1 pi. Okay, ilan ang isang pi? 180, no? So, you can have it as 180 degrees in 1 pi, or 360 degrees in 2 pi. So that's multiplied by 180 all over the pi. So that would become equals to 2.28 degrees. Okay. So this is now the angle of rotation at the end of the shaft. Okay. So again, for the maximum shear stress, you will use the radius. Okay, and then for the angle of twist at the end, it should be yung ang tawag natin ito, it should be the combinations or the summation, summations of both the AB and then the BC. Okay po. Copy. Alright, so let's have the problem number 2. So, the shaft in figure A consists of a 3-inch diameter aluminum segment that is rigidly joined to a 2-inch diameter steel segment. The ends of the shaft are attached to rigid supports. Calculate the maximum shear stress developed at each segment when the torque T equals to 10 kip-inch is applied. Use G equals to 4 times 10 to the 6 psi for aluminum and G equals to 12 times 10 to the 6 psi for steel. Okay. So, ang gagawin natin, since isa lang naman yung load natin, which is the torque T, na mayroong, that is around 10, 10 kip-inch. Okay, so ang value nito is 10 kip-inch, no? So, what I will do is, i-drawing ko muna into dimension, no? So, para hindi tayo mahirapan. Okay, so I'll do a solution. Okay, so I have here, oops, sobra. Isa daw malaki, and then isang maliit. Okay? Tapos ilagay natin yung load. Okay? So, again, kung paano natin na-right thumb. Okay? Dito natin siya ilagay. So, meron ako dong load na 10 kip-inch. Okay? Kip-in. Okay, kip-inch. Okay? Ngayon, tatanggalin ko yung dalawang support. Okay, so kapag tinanggal ko yung support, lagyan natin points A, and then B, and then C. Pag tinanggal ko yung point C, dahil fix siya, so magkakaroon ako doon ng support. So, yan. Tawagin ko na lang siya ditong point C. Okay? Okay, TC. Or, let's have it aluminum na lang, kasi that is steel pala. So, that is steel. Okay? And then dito, meron din. Okay? Which is aluminum. Okay? T, aluminum. Okay? Since pakanan yung ating 10 kip-inch, better siguro kung ang gagawin na natin is pakaliwa, no? Para magtutulong silang dalawa. Hypothetical lang naman. Okay? So, T steel. And then, I will have it as T aluminum. Okay. Ginawa ko to the left kasi yung mga natin is pakanan. Okay. Now, if I'm going to summation, actually that is if this is your axis, which is the x-axis. Okay. If this is your axis, moment yun moment about the x-axis. If we are going to take the moment about mx, of course it should become equal to 0 for equilibrium. So I could say that my 10 kip-inch minus T aluminum minus T steel is equal to 0. Okay. Unfortunately, wala ka nang pwedeng ibang equation na makuha. Yan lang ang pwedeng equation. So, meron kang dalawang unknowns, and then meron kang isang equation, so hindi mo siya kayang isolve. Okay? So, ang tawag natin dito, again, ano nga to? This is statically indeterminate. Okay? Ibig sabihin, hindi natin siya kayang i-solve by just summation forces and then summation moments. So, what we will use is what you call the deformation. Okay? Now, paano yung deformation na yun? Assuming, okay, ito yung unang linya ng natin, at this point. Okay? And then, ayun din yung linya nun at this point. Okay? Ngayon, papaikutin mo yung point B. Okay? Pag pinaikot ko po yung point B, this point, pwedeng mapunta sa point na yun. Okay? So, pwede siyang mapunta sa point na yun. And since it is rigidly attached at point B, pwede rin siyang mapunta sa point na yun. What does it mean? Yung inikot ng steel diameter, iyon din yung inikot ng aluminum diameter. Okay? So, in relation, by compatibility, I could say na yung theta or yung inikot ng aluminum is also equals to the theta na inikot ng steel. Okay? So, this would be our second equation. Now, since ang equation natin for the theta or the rotation is equals to TL over JG, so we can have it as TL all over JG, and this is for the aluminum, and it would become also equals to TL over JG for the steel. Okay? So, um, kukunin natin yan. Ang ating, teka, nawawala yung cursor ko. Oops, sorry. Oops, ano, nawawala ang aking cursor. Okay? And then, what we're going to do is to have it simplified. Okay? Now, yung T natin, T aluminum, ayaw sumulat. Yan. Okay, yun na. T aluminum, we multiplied it by the L aluminum. So, ang L ng aluminum natin is 6 feet. So, that is 6 times 12 all over J. So, that is pi all over 32 pi all over 32 multiplied by 3 to the 4th. Okay, that is for the J. And then for the G, we have ang G natin. Sabi 12 times 4 times 10 to the 6 for the steel, no? 4 times 10 to the 6. Ito po, 4 times 10 to the 6. Should be equal daw yan sa T ng steel. Okay? Ang L ng steel natin is 3. So, that is 3 times 12 all over. So, we can have it as pi all over 32 multiplied it by 2 to the 4th for our J. And then, our G for the steel is 12 times 10 to the 6. Okay? So, ito na yung second equation natin. Now, if we are going to have this one, we could say, okay, this equation, I could say that my TAL is equals to 10 minus TS steel. Okay? So, rearranging the equation. Okay? So, aside from that, we could say that yung 10 natin is nakakip. So, dapat yan, ito kasi is nakakip. Take that in mind. So, para maging pounds yan, it should be 10,000 pounds inch minus TST. Okay, bakit? Kasi sir, naka-PSI yung atin. So, naka-pound per square inch. So, dapat lahat naka-pounds. And then, naka-inches. So, dapat lahat naka-inches. Okay? So, we will take that, the TL. So, yung TAL ko, so I will change that. So, that would become 10,000 minus TST multiplied it by 6 times 12 all over pi all over 32 multiplied by 3 to the 4th multiplied by 4 times 10 to the 6 equal to, para sa steel torsion, multiplied it by 3 times 12 all over pi all over 32 multiplied it by 2 to the 4th multiplied it by 12 times 10 to the 6. Okay? So again, the important here is that yung ating angle ng aluminum, yun din yung naging angle ng ating steel. Okay? Kaya pwede natin siyang ipag-equate. Okay? So, now the only unknown is the TST. Okay? So, it is just the algebra. Pwede nating i-calculate x multiplied by 6 times 10, 6 times 12 all over pi all over 32. O, cancel na natin tong 32. No? Cancel na natin yung 32 na yan. Yung pi over 32. So, this 3 to the 4th multiplied it by 4 times 10 to the 6 is equal din siya sa TST multiplied by 3 times 12 all over 2 to the 4th multiplied by 12 times 10 to the 6. Okay? So, makukuha na natin yung value ng ating TA. Okay? Yan. So, ang aking TA is equal to 5,423.73 pound inch. Okay? So, hindi pa ito yung final answer, but this is our intermediate answer. Apps. What did I do? Yan. So, meron na tayong TST. Okay? So, now, we could solve for the value of TA. Okay? So, for the TA, again, i-ano natin, T aluminum equals to 10,000 minus 5,423.73. So, that is 10,000. So, that's around 4,576.27 pound inch. Okay? So, nakuha na natin yung internal torque in segment aluminum and then the segment steel. Okay? Ang tinatanong is calculate the maximum shear stress. Okay? So, para makuha na natin yung maximum shear stress, okay, pwede na natin gamitin yung nakuha nating formula, no? So, yung maximum shear stress natin for the aluminum, sa aluminum muna tayo. Okay. Okay. So, that would become 16T. T aluminum all over pi d cube. So, that would become equal to, yan na natin, no? Baka hindi naman. Okay, kita pa naman. So, we can have it as 16. Okay, T aluminum natin is 4,576.27 all over. We could have it as pi. D ng aluminum natin is 3 inches cube. Okay, so we could have this aluminum. So, that is 16 times 4,576.27 all over pi multiplied by 3 cube. So, you can have it as 863.21 meg. It's in PSI. Okay. So, this is now for the aluminum. Okay. And then again, ang ating maximum for the steel. Okay. So, again, 16T ST all over pi d cube. So, you can have it as 16. Ang TST natin is 5,423.73 all over pi. And then, ang steel natin is 2 cube. Okay. So, we can have it as 16 times 5,423.73 all over pi multiplied by 2 cube. So, that equals to 3,452.85 PS. Okay, ayan. Kita pa naman. Okay. So, that it's for the maximum shear stress developed through the torsions. Okay? So, kahit magkadikit sila, kung mapapansin nyo, magkaiba sila ng torque. Okay? Kasi yung torque, ang kailangan natin doon is actually the torque or the moment para ma-rotate natin at certain degree yung surface na yon or yung point na yon. Nagkataon na dahil magkadikit yung bodies ng aluminum and steel, at the point B, dapat parehas sila ng rotations. Ano? Hindi naman pwedeng nag-rotate sa point B yung steel ng gantong theta, tapos nag-rotate yung aluminum natin ng gantong theta. Kapag ganon, hindi sila rigidly attached. Okay? Pero sinabi kasi sa problem, they are rigidly joined. Ibig sabihin, pag sinabi natin rigidly joined, isa lang dapat yung movement nila. Okay? So, pag nag-rotate sa point B yung aluminum by a certain theta, iyon din dapat yung rotation ng steel at that point, at the point B. Okay? So, ginamit natin yung equations na yon to solve for statically indeterminate structure. Okay po? So, sige, copy, and then I'll give you time to copy. For questions, you may raise your question. Okay? So let's have the next problem. The four rigid gears loaded as shown in figure are attached to a 2-inch diameter steel shaft. Compute the angle of rotation of gear A relative to gear D. Okay. So kapag ganito, when it comes to relative, parang sinasabi lang naman niya, okay, we need to determine the angle of twist of A from A to D. Parang ganun, ano? Relative to D. Okay? So, given the G, pare-parehas naman sila, no? So, 2-inch naman yung diameter. So, kahit magkakaiba, okay, tingnan natin, ano, kahit magkakaiba yung laki ng gear, pero yung pinaka-shaft natin, same pa rin sila ng 2-inch. Okay, so, okay lang. So, still, we will use the J pi over 32D to the 4. Okay? But first, ang pinakamahalaga dyan is dapat alam natin gumawa. Okay, gawin natin siyang in 2D, no? So, maglagay tayo ng 4 segments. Okay. So, we have the point A, the point B, the point C, and then the point D. Okay? So, I will call it as my point A, my point B, my point C, and then my point D. Okay? Then, lagyan natin ng loadings. Okay? So, yung loadings natin, again, depende. Okay? Yung point A, paano ko siya papaikutin? Papaikutin ko siyang pag ganun, ano? Okay? So, pag ganun. Okay? I hope medyo nakikita nyo kasi maganda to sa board na nakikita eh. Okay? Paikutin. While the point B, papaikutin ko siya in this direction. Okay? Point C, gantong direction. And then point D, gantong direction. Okay? So, ang values niya, 500. Again, this is pound feet, ano? 900. 1,000. And we have 600. Okay. Check natin, no? Bilangin nyo lahat ng pakanan. So, lahat ng pakanan is 1,500. Dapat lahat ng pakaliwa, 1,500 din. So that it would be in equilibrium. Okay? Equilibrium naman siya. Okay. So, time na para gumawa tayo ng cutting plane. Okay? Kunin natin to. So, to get for that, makukuha natin yung sa segment. Okay? So, meron ako ditong 600. So, definitely, ang aking internal force, okay, sa CD. So, again, it should be 600. Okay? Next, pwede ko rin mag-cut on this plane. Okay? Tapos, pipili ako, no, kanan or kaliwa. So, piliin ko ulit yung kaliwa. Okay? So, from there, ayan. Okay. Cut ako, no? But this time, kasama na yung C. So, meron ako ditong 600. And meron ako ditong 1,000. Okay? So, to be equilibrium, kailangan ko ng ilan? Kailangan ko pa dito ng 400. Okay? And then this now will become your BC. Okay? So, mathematical lang. Kailangan lang maging equilibrium siya. Okay? Now, for this segment AB, so I will cut the section here. Pwede ulit akong mamili, kanan or kaliwa. But this time, konti lang kasi yun nandito sa right side. Ito na lang yung pipiliin ko. Okay? So, again, I have here the segment 500. So, the internal force for the segment AB is equals also to 500. Okay? So again, kapag away, we will take that as positive. Kapag towards the cutting section, we will take that as negative. Okay, now, since ang kinukuha natin is rotation from A to B, so I will have denote that. So that would be my rotation from A with respect to D. Okay, again yung gagawin ko, no? Rotation of A with respect to D. So, that would become equals to summation of theta AB plus theta BC plus theta CD. Okay? Now, kunin muna natin yung J. So, yung J naman is pi all over 32 multiplied it by D to the fourth. So, ang D naman natin is constant to the fourth. Okay, so that would become equal to pi 2 to the fourth all over 32. So, that's 0.5 of pi. Okay. So, since constant naman yung JG, by the way, yung JG natin, yung baba, tawag natin dito is torsional rigidity, no? So, that is called torsional rigidity. So, constant naman siya kasi isang material lang naman yung ginamit at same lang din sila ng diameter. Okay? So, ang mababago na lang is yung sa taas. Okay? So, yung TL. Okay? So, sa AB muna. From AB, ang T natin, AB is 500, pero naka-pound foot siya. So, that, i-convert natin. So, 500 times 12. Okay? T, and then ang L niya is 5 feet. So, 5, again, times 12. Plus, yung sa BC naman. So, again, sa BC is 400. Oops. Ayan, that's what I'm telling. Yung AB ko is away from the section, so I will have that as positive. Now, for this one, you will be having here negative. Okay? So, negative, it's because towards the section. So, minus 400 times 12. At ang L niya ay 3. So, 3 times 12. Alright? And then, last is the CD. I will have it as plus. Okay? Kasi, away from the section. So, you can have it as 600 times 12 multiplied by the length, which is 4 times 12. Alright? And then, all over kasi pare-parehas lang naman sila ng JG. So, ang J natin is 0.5 of pi. And then, ang G natin is 12 times 10 to the 6. Again, in PSI. So, everything should be in pounds and everything should be in inches. So, this now would become your theta of A with respect to D. So, theta of A, excuse me, with respect to D. And that would become equal to 500 times 12 multiplied by 5 times 12 minus 400 times 12 multiplied by 3 times 12 plus 600 times 12 multiplied by 4 times 12 all over 0.5 of pi multiplied by 12 times 10 to the 6. Okay? So, you can have it as 0.0283. Again, this is in rad. Okay? So, to convert that into degree, so, ang isang pi ay 180 degrees. So, ang theta natin with respect to D in terms of angle is 180 all over 5. It's 1.62 degrees. Okay? This is now the answer for the problem. Okay? So, if I'm going to ask what is the rotations of A with respect to C, and then you should just have it or add AB plus BC. Okay? So, depende kung saan nagre-respect. But our case, with respect to D, kaya from A to C. So, if this is with respect to C, and then from A to C lang. Okay? So, that's it. You may have time to copy. So, let's have this kind of problem. So, yung pag-ikot kasi, okay, yung pag-twist natin siya during the torque, okay. So, pwede siyang mag-transmit ng power, no? So, di ba kapag meron ka mga gear or yung mga turbine natin, yung mga turbine, although this is normally for mechanical, pero as a part of deformable bodies, no? So, yung pag-ikot niya, kapag pinag-twist mo siya at a certain speed, okay, in radian per second, or what you call the frequency, and magkakaroon yun ng power, okay? It could produce the power, okay? So, in mechanics of deformable, yung pinaka-formula natin, yung torque, okay, na kaya niyang i-produce, okay? So, that would become equals to the power all over 2 pi f, okay? Wherein this is the power, and this one is frequency, okay? For SI, okay, for SI, okay, ang ginagamit natin, yung power, yung unit ng power, it should be in watts, okay, and then yung F natin, it should be in hertz, or ang unit niya is per second, okay, so that's per second, no, 1 all over time, okay. Now, using this one, a solid steel shaft is rolled in a rolling mill, transmit 20 kilowatts. So, given natin, you can have the power equals to 20 kilowatts of power at 2 hertz. So, ang ating frequency ay 2 hertz. Determine the smallest safe diameter of the shaft if the shear stress, okay, so ang allowable natin is 40 megapascal. Okay? And the angle of twist, okay, ang allowable lang na angle of twist is 6 degrees. Ang length natin is 3 meters. At ang G natin, gawin na natin siyang 83 times 10 to the 3 para maging megapascal. Okay? So, unahin natin from this formula. Okay? So, sabi natin yung ating torque, okay, which is ating hinahanap, that would become the power. Kaya lang naka-kilowatts. So, sabi natin, to have this formula para maging consistent, kailangan naka-watts. Madali lang naman. Kilo yon, so you can have it as 20 times 10 to the 3. So, again, that would be the watts. All over, you can have it as 2 pi, and its frequency is in hertz, already in hertz, multiplied it by 2. So, you can have it as 20 times 10 to the 3 watts all over 2 pi multiplied it by 2. So, that would become 1,591.55. Since this is in SI, ang basic unit natin is in Newton, and that would be in meter. Okay? So, that is the torque. Newton meter. Now, ang kailangan natin ngayon malaman, sabi niya, the diameter. So, may dalawang ibinigay na conditions. Una, hindi ka dapat mag-e-exceed sa shear stress na 40 megapascal at hindi ka rin lalagpas sa 6 degrees. Okay? If the problem gives you two conditions, ibig sabihin, dalawa rin yung values na makuha mo. At mamimili tayo doon kung alin yung pinaka-safe. Okay? Unahin natin, due to shear stress. Okay. Again, kukunin natin is maximum. Ano nga yung formula ng maximum? Kapag solid shaft, we can have it as 16T all over pi d cube. Okay? So, the maximum allowed is 80, maximum allowed is 40 equals to 16, and then the torque is 1,591.55 all over pi, and then ang d natin is ilan nga ang ating iyan pala ang hinahanap, sorry. So, pi d cube. Okay? So, makakakuha tayo ng d due to the shear stress. 16 multiplied by 1,591.55 all over pi. the okay, so we will be having here the value of 16t. Oops, sorry. Ito kasi ay naka-meter. Kung gagawin natin siyang mm, ito ay naka-meter, i-multiply natin ito by 1,000, ano? Okay, para lang maging Newton millimeter. Okay, sorry for that. Newton millimeter dapat yun. Okay. So, let's solve for the value of t. So, we can have it as 58.74 millimeters. Okay? Ito ay due to the shear alone. Okay. Pero ang kailangan natin also is due to rotation. Okay? Again, gagamit tayo, that is TL all over kg. Ano? Okay. Kaya lang, yung ating, yung 6 degrees natin, i-convert natin siya dapat into radian, ano? So, para ma-convert yon, instead na 180 over pi, gawin natin, kasi naka-degrees to, so para ma-cancel yung degrees, ano? So, multiply natin by pi all over 180. So, ang ating t is, again, 1591.55. Again, times natin by 1,000. Okay, para maging Newton millimeter. And then, ang L natin is 3 meters, so we can have it as 3,000. Okay? All over the J. So, meron na ba tayong J? So, ang J natin is pi all over 32 and then D to the 4th. At ang G natin is 83,000 in megapascal. Okay? So, be consistent lang sa unit. Again, yung 1591 on yung torque natin, kinonvert natin into Newton millimeter. Yung length na 3 meters, kinonvert din natin into millimeters. And yung ating gigapascal, kinonvert din natin sa megapascal. Okay? So, para consistent. This time, we can now find the value of D. So, 6 times pi all over 180 is equal to 1591.55 times 1,000 multiplied by 3,000 all over pi all over 32 d to the 4th multiplied by 83,000. Okay, so we can now solve for a certain diameter using the rotations. Ngayon ko lang, mabagal yung calculus ko. Okay, so again, if you have two given, okay, two parameters like shear and then the rotations, dalawa din yung makuha. Ito, meron na. So, that's 48.64 mm. Okay, now, check natin ano. Kapag 58.74 ang ginamit ko, ito yung minimum diameter na kailangan para maging safe. Okay? Dito naman, ito yung minimum diameter. Okay? Ang tinatanong kasi, what is the smallest safe diameter? Kasi kapag tinanong is what is the smallest safe diameter, parang ang pinaka nagiging connotation sa utak ng estudyante is ano yung mas mababa sa dalawa? So, ang kukunin nila si 48.64, which is not. Bakit? Let's say ang Arab natin is 48.64. Pagdating sa rotation, ang minimum requirement is 48.64. Pasado siya. Pero ang minimum requirement para hindi mag-exceed ng 40 megapascal ay 58. Eh, ang gagamitin mo lang 48. Papasa ba siya? Hindi. So, ibig sabihin, this is only safe. Okay? This is only safe for rotation, but it is not safe on the shear. Pero kung ito ang gagamitin natin, pasado siya sa shear kasi ang minimum requirement is 58.74. Pasado ba siya sa rotation? Eh, ang minimum lang naman na kailangan ng rotation is 48. Okay? So, that concludes that this is our minimum diameter. Now, ipaparound off natin. Sige. So, again, 2. So, pwede natin sabihin 60 mm. So, this is the minimum size, okay, na kailangan natin. Na, pwede na ito na, pero pag depende sa problem, pag pinaparound up ko, let's say, multiple of 2, parang yung sa quiz nyo, so that would be 60 millimeters. Okay? Any question? So that solves this question. So let's continue for the power transmission. So a hollow steel shaft 6 feet long has an outside diameter of 3 inches and inner diameter of 1.5 inches. The shaft is transmitting 200 HP. So yung HP is a unit for power, no? At 120 revolutions per minute. So ito yung kanyang speed, okay? So determine the maximum shear stress in the shaft and the angle of twist of the shaft in degrees. Okay, now, kapag ang given is English unit, okay? So kasi kanina, may formula tayo, di ba, na power all over 2 pi f. Okay, now, pag kinonvert natin yan into English, bibigyan ko na kayo, no? So, hindi ko na pinakita yung pinaka derivation. Anyway, meron pala sa libro ni Q. Salas. Okay, this one is also problem from Q. Salas. So, yung torque na matatransmit natin for English unit, no? Okay, the power transmission would become equal to 63 times 10 to the 3. Okay. And then, of course, this is in the power all over. We can have it as the frequency. Wherein the unit for this should be in HP and the unit for the frequency is in revolution per minute. Okay? So, again, meron naman tayong power. So, this is 200 at meron tayong revolution per minute. Okay? So, pwede natin makuha yung pinaka-torque natin. So, let's solve. For the T, that would become equals to 63 times 10 to the 3. And then multiply natin, yung power natin is 200. All over ang ating is 120. Okay. Kapag hindi, kuwari naka-rad per second siya, you need to convert for revolution per minute. Okay. So that would become equal to 63 times 10 to the 3 multiplied by 200 all over 120. So you can have it as 105,000. Ang unit is in pound inch. Okay? Okay lang na naka pound inch kasi yung ating G is naka PSI. So pounds and inches. So tama lang yung ating pound inch. Okay, now we can now solve for the J. Okay, so again yung J natin, this is a hollow steel. So, paano nga yung hollow steel natin? Pi all over 32. Quantity to the fourth minus D to the fourth. Hollow. Okay? So, let's have it. Pi all over 32. And then, ang diameter natin is outside diameter 3 inches. And then, ang inside diameter natin is 1.5 inches. Okay? So, you can have it as times 3 to the 4th minus 1.5 to the 4th. Okay, so that is 7.455 inches to the 4th. Again, to the 4th tayo, ano? That's the polar moment of inertia. Now, ang tinatanong is the maximum shear stress. Okay, this is a hollow, no? So, again, pwede natin gawin, that is TR all over J. Kasi meron na tayong J. So, yung T natin, again, 105,000. Okay, now, how about the R? Ano ang gagamitin kong R? Is it the inside or the outside? Okay, so, note, if this is the inside, the outside, and this is the inside, note from here, pwede magkaroon ng stress dito. Okay, so, yan yung maliit na R mo. O, yan ang gagamitin mo. Pero, pwede rin dito, yung malaking R. Alin na magpo-produce ng mas malaking shear stress? Yung maliit na R o yung malaking R? So, definitely, yung malaking R. So, ang gagamitin natin dito is yung diameter ng mas malaki. Okay? So, you can have it as 1.5. Okay? Kasi 3 inches yung malaki. So, you can have it as 1.5 all over the J. So, that is 7.455. So, you can now solve for the maximum shear stress multiplied by 1.5 all over 7.455. So that is equal to 21,126 0.76 again in PSI. So this is now the maximum shear stress. Now, angle of twist. So again, we can have it as T L all over J G. So again, ang T natin is 105,000. Ang L natin, 6 feet long. So, i-convert ko siya by inches. Okay? Ang J natin is 7.455. At ang G natin ay 12 times 10 to the 6. Okay? So, yun. So, you can have it in region. So, we can have it as 105,000 multiplied by 6 times 12 all over 7.455 times 12 times 10 to the 6. That is equal to 0.0845. Again, this is in rad. To convert that into degree, so you can have it as 180 degrees per pi. So that the angle of twist is 180 is 4.84 degrees. Okay. So, those are the problems. Kapag English, again, kapag English unit yung ginagamit, the power should be in HP, and then the frequency should be in revolution per minute. Okay po? So, any question? Okay. Sige po. Kopya. Okay, so let's have this problem. The steel shaft with two different diameters rotates at 4 hertz. Okay, the power supplied to gear C is 55 kilowatts, of which 35 kilowatts is removed by gear A and 20 kilowatts is removed by gear B. So find the maximum shear stress in the shaft, and B, the angle of rotation of gear A relative to gear C. Use G equals to 83 gigapascal for steel. Okay, now, parang torque, parang tensile, so nagsusupply din, sabi ko nga, ng transmission power yung kada gear. Okay? However, sa gear C daw, pag supplied ang term natin or nagsusupply siya, we will denote that as our positive, no? So that's positive 55 kilowatts. Yung remove, and then nare-remove daw ng gear A, so that is negative 20 kilowatts. And then yung gear baliktad. 35 okay, kilowatts is removed by gear A, and 20 kilowatts is removed by gear B. So, dapat yung power, again, equilibrium din, na? So, you have 55, and then lahat ng negative, 35, and then 20. Okay? Now, to solve for that power transmission, okay, on the certain parts, we have the part of AB. Okay, yung power ng AB ganun din. Pwede kang mag-cut, okay, and then you choose either right or left. So, para makuha natin yung power dun sa shaft na yon. Okay? So, ngayon, mag-cut ako dito, sige. Pero piliin ko na yung left side. So, makakuha ako ng 35 kilowatts. Okay? And then, for the BC, ang power, pwede ako mag-cut dito. And then, you choose either right or left. Same lang yung magiging result. So, kunin ko na lang yung right side. So, that is equals to 55 kilowatts. Okay? So, hindi ko na masyadong detailed, ano? Kasi, madalas na natin gawin yung cutting and then equilibrium. Okay? So that we can now have the torque, okay, at segment AB muna. Again, this is in unit ng SI or System International. So, we will having here the T, okay, P all over 2 pi and then F, wherein the P should be in watts and then the F should be in hertz. Okay? So, naka-hertz naman except that naka-kilowatts. So, yung 35 kilowatts, gagawin nating 35 times 10 to the 3. Okay? Para maging watts. Okay? All over 2 pi, and then ang frequency is 4 hertz. So, I have now the power for torque times 10 to the 3 and 2 pi times 4. So that is equals to 1392.61. Again, this is in Newton meter. Same thing, I could now solve for the BC. So same, the power all over 2 pi F. So that is equals to 55 naman kasi we are now on the BC times 10 to the 3. Okay, again, this is in watts all over 2 pi, and then you will be having here the 4 hertz. So 55, so you can have 2,188.38 Newton meter. Okay? So, ito na ngayon yung internal torque na nare-receive ng kada segment. Okay? So, kukunin natin, syempre, yung maximum sa dalawa. So, to solve for the maximum, okay, max, unahin muna natin at AB. Okay, solid shaft naman siya, so we can have it as 16T all over pi d cube, ano? So, 16T all over pi d cube. So, we can have it as 16, and then the torque ng AB is 1392.61. E times 10 to the 3 ko na, no? Para maging Newton millimeter. Para consistent tayo. And then pi, And then, ang D ng segment AB is 55 mm. Okay. So, you can have this stress. So, that is 1392.61 times 10 to the 3 all over pi 55 cube. Okay. So, you can have it as 42.63. Again, the unit should be in megapascal. Hindi pa yan yung sagot. So, meron pa kasi tayong segment BC. Same thing, ganun pa rin. 16t all over pi d cube. So, we have here 16. But for the BC, ito na yung gagamitin natin. Sorry. Nasa na yung BC? Ito pala. Sorry. 2,188.38. Again, times 10 to the 3 para maging Newton millimeter. And i-divide ko by pi. Ang D for the segment BC this time is 65 cube. Okay. So, you can have it as 16 times 2188.38 times 10 to the 3 all over pi 65 cube. So, you can have it as 40.58 megapascal. Since ang tinatanong is the maximum shear stress, pipili tayo sa dalawa. 42 or 42.63 or 40.58. So, definitely, ito yung ating kukunin. Okay? To give you clue, okay? Kapag ang tinatanong sa problem ay stress, okay, ang pipiliin natin doon is yung pinakamalaki. Kaya kapag ang tinatanong doon is yung mga sizes ng member. So, diameter, inner diameter, or diameter, kukunin natin din yung pinakamalaki. As in, pinakamalaki din. So, magulo pala. Since ang tinatanong dito is the maximum shear stress experienced by the body, so AB and then BC, so either of the two, mas malaki yung nakukuha ng segment AB. So, definitely, ito yung magiging malaki. Okay? Ito yung ating maximum shear stress. Next, angle of rotations of gear A relative to gear C. So, ganun pa din. So, we can have it as parang, tawag natin dito, theta of A with respect to C. So, we can have it as theta A, B, plus theta B, and then C. Okay? So, ayan. For this time, again, we could add only the two. So, TL all over JG. For the AB, TL all over JG for the AB. And then we can have it as TL all over JG for the BC. Okay, wait, baka hindi na ako kita. Okay. So, parehas naman sila ng G. Okay, iyan ko na yung G. So, sa AB muna tayo. We have 1392.61 times 10 to the 3, no? Para maging Newton millimeter. And then, your L. Yung L ng AB, which is 4 meters or 4,000 mm. All over the J. Ang J natin is pi all over 32. And then, D to the 4th. Okay? And then, ang G natin is 83,000 para maging mega pascal. Okay? And, i-add ko yung para sa BC. Okay, dito na lang sa baba, ano? So, again, that is 2188.38 times 10 to the 3. And then, the length is around 2,000 mm. So, 2 meters. All over. The J is pi all over 32. And then we can have it as 65 to the 4th diameter. And then multiplied it by 83,000 MPa. Okay. So, this is now with respect to C. So, we can have it as 1392.61 times 10 to the 3. 4,000. 55 to the 4th multiplied by 83,000 plus 2188.38 times 10 to the 3 times 2000 all over pi all over 32 multiplied by 65 to the 4th times 83,000. Okay? So you can have it as the value for my, so that is equals to 0.105 in a rad. Okay? Multiply natin by 180 all over pi para maging degrees. So that's around 6.00 degrees. Okay? So this is now the answer for the second question. So again, dito, kinocompute natin is the power shaft and then convert it into torsion, and then we convert it into stresses, and we compute also for the strain, or what you call the elongation, or what you call the rotation pala, or for the torsion. Okay, so that's for the question, and I'll give you again another 5 minutes to copy, and if you have question, you can raise your question.
Okay, so let's have the problem sample for mechanics of deformable bodies. So, sample problem lang. So, both ends of the steel shaft are attached to rigid supports. Find the distance A, where the torque T must be applied so that the reaction or the reactive torques at A and B are equal. So, ito yung A. So, this is the point A. Okay, and this is your point B. Okay? So, kung hindi natin may 3D, ito 2D natin, ah. So, ito-2D muna natin. So, for example, this shaft, okay? So, the first shaft, so let's have this as a rectangular, okay? And then we have here on the second shaft, yung mas maliit. Okay, point A and then point B. Okay, at a certain point on the second section, we do not know. So, pwede kasing nandito siya or nandun sa kabila, no? On the first shaft or on the second shaft. So, ang gagawin natin, since given naman is nandito, so we will try first to assume that this torque is on the second shaft. Okay, so lagay natin dito sa point na to. Okay? Kaya lang, on the 3D part, gagawin natin siyang 2D. Normally, the torque on the 2D plane is represented by two-headed arrows. No? So, it always follows the right thumb rule. So, right thumb rule pa rin tayo. So, it turns out to be a counterclockwise manner. So, on the right thumb, pag ganon, so parang pinapaikot ko yung second shaft. So, this shaft, I try to turn it on this direction. So, kung saan nakaturo yung right thumb ko, dun din nakaturo yung torque natin at this point. So, I will have this one to be my torque T. Okay? So, ngayon, ang sabi sa given, hahanapin natin yung distance nun. Okay? So, we'll find distance A so that the reactive force, pagtutulungan nilang dalawa tong T, so tig-kalahati sila, no? So, they would be equal. So, dapat daw, this point, and then this point, merong kang tig-T all over 2. Okay? Para pag nag-summation forces ka, horizontally, so technically, you have a zero resultant. Okay? Now, for this type of problem, ang gagawin natin with the concept of what we call the compatibility, no? So, sabi natin, dapat yung reactions o kaya yung deformations na nake-create ng external body should always be equal to the deformations created by the internal body. So, this one, because this is an applied force, we call it as external force. Okay? So, this is called your external force. Okay? Yung dalawang reactive force, because we remove the support, and once we remove something, so parang method of sections natin, once we remove something, nakakapag-expose tayo ng mga forces. And by this time, nung ni-remove natin si support A and then si support B, nagkaroon tayo ng dalawang reactions, which is T all over 2. So, this 2 is called internal force. Okay? So, ngayon, sabi niya, dapat daw yung deformation na makikreate kapag in-apply sa external force. For example, ito, kung i-apply ko si torque alone, wala yung dalawang forces na to, dapat yung deformation niya dito, same sa deformation kapag yung isa lang ang in-apply ko. Okay? Ang gagawin kong technique, uunahin ko muna, okay, yung internal force ko muna. Okay? So, for the internal force, okay. So, i-drawing ko ulit yung dalawang bar. So, this is the first bar in C. Ibalik ko muna yung support sa B na. So, para meron akong point of support. Okay? So, meron nga diyang rigid. Okay? Pero ngayon, ang i-apply ko lang muna, since meron na akong support dito, hindi ko muna i-expose T all over 2. Okay? Tapos, ito, since wala akong support dito, I will apply here my T all over 2. Okay? So, again, this one is L all over 2. And then this one is also L all over 2. Okay? So, kailangan natin makuha yung kanyang J. Okay? So, yung J natin para dito, ano yung formula? Pi all over 32 multiplied by D to the 4th for the circular shaft. Okay, solid. So, hindi naman siya hollow. Ngayon, meron akong D dito. Ngayon, at point A, kaya kong makuha. Okay? So, imagine nyo, okay, wala pala akong ruler. Nasaan yung ruler ko? Ito, medyo malambot na ruler. Okay. Parang ganito yung shaft natin, no? Kung papaikot ko, this is the rigid support. Tapos, meron akong torque dito na L all over 2. Dito ko siya papaikutin. Okay? So, kung makikita nyo, yung movement dito, may makukuha akong rotation. Okay? So, I will solve for the theta A for this one. So, I will have my theta A. Okay? Due to this one, dapat buo, no? Kasi yung buo na to, magre-react yan ng buo. Okay? Kumbaga, pag inikot ko to, buong shaft ko, umiikot. So, ibig sabihin, included siya. Okay? So, we will have it this way. So, we can have it as TL all over JG. Formula for the N. Okay? So, this would become TL over JG for the first shaft. And we will have it TL all over JG for the second shaft. Okay? So, for the first shaft, we can have it T all over 2. Okay? T all over 2. And then we will have it as L, which is L all over 2. And then we will have it the J, pi all over 32, multiplied it by D to the 4th. However, on the second shaft, it will still have the same na. Kung ikakat ko to, okay, makaka-expose din ako ng T all over 2. So, it means that the force on this one is still T all over 2. So, we can have it as T all over 2 multiplied it by L all over 2 over, this time ang J ko, pi all over 32 multiplied by 0.75 of D to the 4th multiplied it by G. So, this is now the rotation at point A caused by the internal force. So, punta tayo naman sa external force. External force. Okay? Okay, so let's have for the external force. So, i-drawing ko ulit to. Okay, so I will have this shaft. Okay, and then another shaft. And then it is fixed. This time, ang ilalagay ko naman yung aking external force or yung external torque, which is the T. And that is distance of A. Okay? And yung natitira nating distance, this would become L minus A. Yung buo is the length L. Tapos, we will have it as L minus A. Okay. Now, kukunin pa rin natin yung rotation ko at A. So, again, we can have it as TL all over JG. Okay? Kaya lang, on this one, hindi ko isasama yung first bar. Okay? Bakit? For example, I have here the second bar and ito yung first bar ko. So, ito is blade. Okay? So, dun sa unang example, nandito kasi yung torque ko sa dulo. So, kung dito ko siya papaikutin, tutulong yung dalawang bar para mag-rotate yung point A. Okay? So, mas madaling salita, for example, napakalambot nito, tas ito napakatigas. Okay? Pag pinaikot ko dito, okay? So, may kinalaman yung tigas nito dito sa point A. Okay? Kaya parehas ko siyang isinama. Kaya lang, pagdating dito sa second, nandito na yung force ko. Okay? Tapos ito free, no? Walang support dito. Pag papaikutin ko to dito at this point, sasabay lang to. So, in short, walang kinalaman kung gaano katigas to when it comes to rotation at A. So, ang may kinalaman ngayon sa kanya, itong bar lang na to. So that, we will just focus on the second bar. Second question, ano yung gagamitin kong L? Okay? Siyempre, yung gagamitin kong L, may kinalaman din siya sa rotation to. Kahit saan ko dito ilagay, okay? Example, pareha silang free, no? So, kahit saan ko dyan ilagay, itong part na to, mula sa point A hanggang dun sa force, walang kinalaman. Okay? So, kasi free yun walang ibang force So, kahit paikutin ko siya, kahit gaano pa siya kahaba, basta pinaikot ko rito, same pa rin yung rotation. Pero, may kinalaman siya ngayon, mula dito sa force or sa torque ko, hanggang dun sa aking rotation. Okay? So, imagine, kung itong ruler na to, okay, is sobrang haba. Kung dito ko siya papaikutin, mas madali siyang paikutin. Okay? Tama ba ako? Mas madali siyang paikutin. Kung nandito yung torque ko, mas madali ko siyang paikutin dahil mas mahaba yung length ko. Pero, mentrans lumalapit yung torque ko dun sa support, mahirap na siyang paikutin. Okay? What does it mean? Yung L na gagamitin ko is yung L from the force torque T hanggang dun lang sa aking support B. And this time, that is our L minus A. So, we will have it as torque T multiplied by L minus A all over pi all over 4. Since this torque is applied on the second bar, we can have it as 0.75 of D raised to 4 multiplied it by G. Okay? And then from the compatibility, that the deformation created by the internal force should be equal to the deformation created by the external force. So these two should be equal. Okay? So pag i-equate ko yun, i-rewrite ko lang to. So theta A due to the internal should be theta A due to external. So we can have it as T over 2 multiplied it by L all over 2 all over pi all over 32 multiplied it by D to the 4th multiplied it by G. Plus, so we can have it as T over 2 multiplied by L over 2 all over pi all over 32 0.75 of D multiplied it by G equal to T multiplied is by L minus A all over pi all over 4 multiplied by 0.75 of D to the 4th of G. Okay? So this is now our equation. So pwede kong i-cancel si T. Pwede kong i-cancel si pi all over 32. 32 to. Pwede kong i-cancel si D to the 4th. Cancel si D to the 4th. Pwede kong i-cancel si G. So, this time, ang matitira dito is L all over 4 for this term. Dito is matitira is L all over 4. Kaya lang may natira sa baba na 0.75 raised to the 4th. Is equal to, dito ang natira is L minus A all over 0.75 to the 4th. Okay? So, simplifying, ito pwede kong paghiwalayan, no? Algebraically. So, we can have it as, ito pag sinimplify ko, so I'm still using the 991ES, masanay ako dito. L all over 4 plus 1 all over 4 times 0.75 raised to 4. So, we can have it as 337 of L all over 324. So, equal to, ito pwede kong paghiwalayan, I can have it as L all over 0.75 raised to the 4th minus A all over 0.75 to the 4th. Okay? So, I will have this one as A, ilipat ko to sa kabila, 0.75 to the 4th. So, that would become equal to L all over 0.75 to the 4th minus 337 of L all over 324. Simplifying, I can solve for the A. So, we can have it as 1 all over 0.75 raised to 4th minus 337 all over 324. So, that would be L. So, this would become equal to 2.12 for this term. 2.12 of L multiplied it by this one, 0.75 to the 4th. So, your A times 0.75 raised to 4, your A is 0.671 of L. Okay? So, since this is more than half, our assumption is correct that the torque must be applied on the second shaft. Kasi kung ang lumabas dyan is less than 0.5, it means that the torque lies on the first bar and our assumption is now incorrect for this one, for the external force. Okay? So the answer is 0.671 of L.